Hello, I'm Mrs. Neill, and this is Mrs. Neill's geometry lesson number 13, special segments in triangles. What we're going to learn today are 4 types of special segments that are associated with triangles. What you need to know today is median, altitude, angle bisector, perpendicular bisector. What I would recommend you doing is to draw the picture and also write down the definition of each one of these items. You need to be able to recognize them through a worded definition and also through a picture. So feel free at any time to stop this video and do that. Let's look at our first one, which is median. When I think of median, I think of a median of a highway. And let me show you why. Okay, so our first definition is a median is a segment that connects a vertex of a triangle to the midpoints of the opposite side. So when I think of median, I think of midpoint and equal segments. So let me talk about what that means by showing you a picture. A median is a segment. So this is our median right here that I'm highlighting in red ink. That is what we're trying to discuss today. And it connects the vertex of a triangle, see there's a vertex right there, B, to the midpoints of the opposite side. So I'm going from B, which is our vertex, down to the opposite side. And what it does is this line cuts this line segment AC into 2 congruent parts. It's kind of like the median of a highway. That's the grassy area in the middle of the highway. And then you have equal lanes on each side of the highway. So that's what median means. Think of middle. So what I'm going to do now is draw some examples of this. So here's our first example. And if you need to stop the video and copy this down and draw pictures, please do so. So we're going to draw the median from A, the vertex A, angle A, and label it AM. What I like to do when I'm drawing, I like to draw my triangle where it looks kind of like a pyramid. See how it peaks up here at the top? I turn my paper around so I get a good visual. So I want to take the median from A, and I'm going to draw a line segment in the middle right here at CB. So I need to find the middle of CB. And you can either measure it with the ruler or just really estimate. I'm going to guesstimate right here. I'm going to say that's the middle. So I'm going to draw the line segment now. And it is helpful to have a straight edge to do this, be a little more accurate. Okay, so that's my median. This red line is the median. And what it did, it went from this vertex and it divided this line segment to 2 equal parts right there. And I need to label this line segment AM. So I'm going to put an M right there. Okay, let's look at the next example. I'm going to draw the median from A and label it AM. So what I'm going to do is I'm going to turn my work around. So A is right on the top, kind of like a pyramid. And this is my bottom. So I'm going to go from this vertex and I'm drawing a line segment that's going to cut CB in 2 equal parts. So I'm going to be going somewhere about right there. CB, what you do is look at the middle. Where's the middle of CB? It looks like it's about right there. So I'm going from this point to that point. If you notice, it looks like it's slanted, but that is okay. So this is our median. This red line is the median, and we're going to name it AM, line segment AM. Okay, so that right there is the median. Let's go to number 2, the altitude. When I think of altitude, I think of airplane, and I'll explain that in just a minute. If you notice, this definition is a little longer. Feel free to stop the video and copy it down. You need to know the definition, the worded definition, and also the picture of it. An altitude is a segment that has one endpoint at a vertex and the other endpoint of the line containing the opposite side so that the altitude is perpendicular to that line. Note, the altitude of a triangle is not always inside the triangle. So when you think of altitude, think perpendicular, think right angles. Okay, so I'm going from the vertex B and I'm just dropping straight down. Don't worry about it being in the middle of line segment AC. I'm dropping straight down so that it's going to be perpendicular to AC. And see right here, it makes right angles. It's perpendicular. All right, let's look at an example. Right here, we want to draw the altitude from A and label it AX. Okay, again, I'm going right here at A. I'm going to turn my paper around to give me a better visual. When I think of altitude, I think of an airplane flying up in the sky. And when they measure the altitude, what do? They drop straight down. When you measure the altitude, you're not going to go sideways or to the side. You're going to, wherever you are, you drop straight down. And if you notice, this altitude is not in the middle of CB. And when you drop straight down to the ground, it forms perpendicular lines. And that gives you a nice right triangle over here, a nice right triangle over there. And these create right angles there. Okay, let's look at another one. Let's draw the altitude from A down to the ground here. So here's my airplane A. Notice this is an obtuse triangle. It's wide. And I'm going from A and I'm dropping straight down to the ground. If you notice, this is an example of where the altitude of a triangle is not always inside the triangle. This is the only one of these four that doesn't have to be outside the triangle. In some cases, it's not. So what I want to do here is extend my ground a little bit. I'm going to extend it right there. And I'm going to go from here. Here's my airplane. I'm dropping straight down, and I'm creating an altitude right there. See the right angle? So this line segment right here, and we're supposed to call that AX. I didn't label it over here. AX, there it is right there on that one now. AX, this line segment right here, is the altitude of this triangle right here. Okay, let's go on to number 3. Number 3 is angle bisector. And here's our definition of angle bisector. So what you're doing with angle bisector, it's a line segment that's going to bisect an angle, one of the angles of your triangle. So an angle bisector of a triangle is a segment that bisects an angle of the triangle and has one endpoint at the vertex and the other endpoint on the side opposite that vertex. So when you think of angle bisector, you think of bisects and equal angles. So what you're doing is you're creating a segment that's going to cut that angle right into two congruent angles. It doesn't mean that it's going to be a median. It bisects it. It doesn't matter where it hits line segment AC as long as it hits that side and it bisects these two angles. Your goal is to have equal angles on each side there. Okay, so let's look at an example. We want to draw an angle bisector from A and label it AN. So once again, I'm going to turn my paper. So what I want to do is I want to bisect this angle A right in the middle. So it's going to be right here. See how that looks like that portion is equal to that portion? It doesn't matter where it hits BC as long as it hits it. So I've kind of looked like I've got it equally bisected, and then I'm just going to draw a line here. This doesn't necessarily have to be congruent segments now that it's been bisected. Okay, all you have to make sure is you bisected the angle. And we want to call that AN right there. Okay, so that's our angle bisector. Let's look at another one. Here's another little triangle here. I want to draw an angle bisector from A. I'm going to turn my paper, and I'm going to call it AN. Okay, so there's my angle. What I'm going to do is just arc it, and I'm going to pick a point that looks like it's on either side of there. And see how it's going to go right there. I need to keep going though, and I need to go through line segment CB. I need to go through the other side. Whoops, okay. Get that drawn. All right. As long as it looks like the angle is cut into two equal parts, that's great. And I'm going to call that AN right there. All right, our fourth one is called perpendicular bisector. Okay, and this one has two components to it. So let me read this. Perpendicular bisector is a segment or line that passes through the midpoint of a side and is perpendicular to that side. No, does not always pass through a vertex point. So it's going to be a midpoint of a side and is perpendicular to that side. So it's got two conditions. So a perpendicular bisector, remember, equal segments plus right angles. So this is our perpendicular bisector right here where this red line is. If you notice, it's going through line segment AC at the midpoint. So we want to tick mark these. And it is perpendicular to AC. So it's going to create right angles right there. So perpendicular bisector is a little tougher because you have to remember more things with it. So let's look at an example. Draw the perpendicular bisector to AB and label it K. So I'm going to intersect AB. Here's line segment AB. You're not even looking at an angle. It does not always pass through a vertex point. So I'm not going from C through AB. I'm just looking at AB all by itself. Two things. I want to find the midpoint of this. So that looks like that about right there's the middle. And it's got to be perpendicular to this right here. So I want to make sure that that forms a nice right angle. So here I go. Looks like it's going through about right there. I'm guesstimating this. So to be able to label it correctly, I'm going to name that K. There we go. And it's got to be a midpoint. So these two sides are equal. And it's got to be perpendicular. So I've got to get the right angles in there. Okay, so you've got a little more marking. You've got to put your equal sides and then your right angle mark there. Okay, let's look at one more. Here's our other example. So we want to draw the perpendicular bisector to AB right here and label it K. So I'm not even looking at the vertex of an angle. All I'm doing is looking at AB right now. And I've got to go right in the middle of this. So it's about right there. And it's got to be perpendicular to this line. So I'm using my straight edge because I need some help drawing this correctly. And I'm lining it up so that it looks like it's perpendicular. There we go. Now I have to mark it. If you just leave your answer like that, it's not correct. I have to know through the markings that you know that's a perpendicular bisector. So I've got to have a midpoint. These two segments are equal. And I have to show that it's perpendicular with the right angle symbol. There we go. So that is perpendicular bisector. Okay, now I want to do one more thing before we finish. What I'm going to do is cover this up and we're going to have a little quiz. Okay, so here's number one. Out of all of our four special segments, tell me which one that one is. Okay, think about that. If you need to stop the video, do that. Okay, which one is that? Which picture does it match? That's going to be angle bisector. All right, next one. What is this one right here? Whoops, let me cover that up. Which one does that look like? Think about it. Look at the markings. I've got segments here. It bisected that, and that's a right angle. Which one is that one? Okay, look at the picture. That is perpendicular bisector. You need to recognize the picture and know the definition of it. All right, let's look at another one. If you notice the markings, it just knows that this section and that segment right there, these two segments are congruent to each other. So it looks like it divided it in two. Which picture does that match? Okay, if you said median, that is correct. Okay, one more. Here we go. If you notice the only thing on this one marked is the right angle, okay, and that means it's perpendicular. So which one is that? It's not perpendicular bisector. Which one is it? It's going to be altitude. All right. That is our lesson for today. I'm Mrs. Neill. Thank you for listening.